Welcome to a lovely Saturday. Well, in fact, welcome to a data Saturday. So this is the first, and I hope, of many data Saturdays hosted by Italy today. Now, on Twitter, the hashtag is #DataSatPN. So join in the conversation because there are a whole host of rooms and sessions going on all during the day. There's loads of content, and I am very excited to be able to present my session. This is going to be my first full-length session around Synapse Analytics and Power BI. So thank you to the organisers of Data Saturdays for allowing me to present. I really hope that you get something out of this, you enjoy it, it'll raise questions. Ultimately, I'm approachable, reachable out on Twitter. We'll go through my contact details in a minute. Love to carry on the conversation there. So I welcome you to Data Saturday number 1, harnessing Azure Synapse Analytics Serverless SQL pools in Power BI Dataflows. Now, my name is Andy Cutler. If you scan the QR code, then you'll be able to get some contact details about me. I'm essentially an independent consultant and contractor, and I specialize mostly in the Azure data platform and Power BI. So think Synapse Analytics, Data Factory, streaming analytics, SQL database, a little bit of Databricks, just a little bit. And my website's available at datahigh.co.uk. I blog every so often, and my Twitter and LinkedIn details are available there. So really, for our session contents, we're going to look at some general concepts around Synapse Analytics and using Synapse with Power BI. So we want to know, well, who is Synapse for? Who is this session for, rather? Essentially, why would we want to connect Power BI to Synapse Analytics? Essentially, well, what are Power BI data flows? We'll have a look at the serverless SQL engine itself. There are sessions that go into the serverless engine and Synapse Analytics in a much more greater detail. And we'll look at, well, why do serverless SQL pools and data flows, why would we want them to work together? So really, when we're talking about who is this session for, we're also looking at, well, who can get involved in this process as well in using Power BI data flows with Synapse Analytics. So we've got some roles. We've got data warehouse developers and data engineers that may work with Synapse Analytics to build either big data processing systems or structured data warehouses. On the Power BI side, we've got data analysts, people who are making sense of that data. They're building reports, they're building analyses to deliver to the organization. And we've got BI developers who are focused on creating data models. They're taking that data and they're transforming it into something that can be used by the business. And of course, I'm not saying that these roles are pigeonholed. You could have one person that does all of these roles in an organization, dependent on the size of the team. But it's important to note that if these positions are different, if these roles are different, then it makes sense to work together, because a data analyst or a BI developer on the Power BI side can be talking to a data warehouse developer or a data engineer on the Synapse Analytics side, and they can work together, okay? Because that data engineer can say, look, I think I can help your Power BI estate. And the Power BI side will think, okay, that sounds quite good. Now, Power BI already has a connector. We could already natively connect to Azure Data Lake Gen 2. So why really do we want to be using another service, a service that's chargeable? It costs money. We'll come on to that later on. Now, Power BI can connect to Azure Storage or Data Lake Gen 2 out of the box. There's a connector, as you can see, available. That's within Power BI Desktop. That's within the Power BI service when you're creating data flows. And you can connect to a URL, your data lake URL, at any point in the folder structure. The Power BI is going to pull those files in recursively. So as files are loaded into a folder, when you refresh Power BI, it will select those files. However, even though Power BI is really great for connecting to Azure Storage, pulling the files in, any processing, any transformation is really going to be done by the Power BI engine itself. Now, if the volume of the data grows in the data lake, or transformations are affecting performance, you are transforming that data in Power BI to such an extent that now Power BI is having to do a lot more work when it's pulling that data in, it's breaking those files open, it's getting the data and transforming. Serverless SQL can take that heavy lifting away from Power BI. It's not to say that Power BI is doing anything wrong, far from it. Absolutely fantastic. It's just that Serverless SQL can now do that heavy lifting of connecting to storage and processing that data. So when we're looking at data flows specifically, we're talking about the data flows in the Power BI service, in which we can connect to a variety of data sources, databases, files, web services. We're cleansing, we're transforming that data, we're turning it into tabular data sets to build data models from. And we're creating a centralized repository of data ready for use in Power BI. Now, the centralized repository is very important because with data flows, you're loading your data in, you're making it available at a centralized location within Power BI for data analysts and BI developers to pull that data from. Now, with the Serverless SQL pool, it's one of the processing engines that's available within Synapse Analytics. And essentially, its reason for existing is querying data, file-based data that's sat in Azure Storage and Azure Data Lake Gen 2. It can also connect to Cosmos DB using the linked endpoint. That's out of the scope of this session, by the way. So we're able to query data in place. So Serverless SQL does not store data itself within its own engine. It's purely metadata driven. So when you're selecting data from your data lake, you're returning that to the client, could be the Azure Synapse Studio or Power BI Dataflows. But we're also able to write the data using a CTAS, a create external table as select, which will write the results of a query, a select statement, back out to the data lake storage. Okay, so it's an important consideration that it does not store data itself, unlike the dedicated SQL pools, which is the data warehouse service. And it exposes a SQL endpoint in which we can connect our BI tools, our software that can connect to SQL, to Azure Synapse. And as you can see, we've got some examples at the bottom of connecting using the open row set process, and we are connecting to a data source. We'll show this in the demo. And I've got a Parquet file format in which I'm selecting that data from. Again, we'll go through that. So Working with Serverless SQL and the Power BI Dataflows together. Now, Power BI is going to connect to the Serverless SQL endpoint. Okay. Now, the Serverless SQL endpoint is a SQL endpoint. Like the dedicated SQL endpoint, you can connect to it. So with Power BI Dataflows, we are connecting to that Serverless SQL endpoint that looks, well, like a SQL database endpoint. And within Synapse Analytics, we can create an external table, the only type of table that's supported in Serverless SQL, to cast a structure over files in a data lake. In this example here, you can see that we've got a location with fact internet sales big / Parquet. My data source and file formats are pre-configured. Okay, so data source will point to my data lake, and my file format will tell the create external table what kind of file to expect. Ultimately, within the Power BI data flow, when I create that data flow, I can see that external table as an object, well, just like I was querying a SQL database or dedicated SQL pools. So if you've got CSV or JSON or Parquet, then in storage, in your data lake, then it's entirely feasible to let Serverless SQL do the processing for you, do the transformations for you. If you have a large amount of data, if your data strategy, if a project requires you to be using large volumes of data into Power BI, create a data flow and use the Serverless SQL pool to process that data and pull that data in. Now we're going to come onto this feature in a little while, but that third line at the bottom, query folding, that's going to play a key part in why we would want to use Serverless SQL with Dataflows. So just taking a sidestep for a minute in terms of the overall Azure Synapse Analytics service, because there are a few processing engines and a few features that make up the whole suite of Azure Synapse Analytics. Serverless SQL is one of those engines. Now, in this context, we can simply use Azure Synapse Analytics as a Serverless SQL processing engine. So when we create a workspace, when we create an Azure Synapse Analytics workspace, we automatically get a Serverless SQL pool created by default, and it's immediately available for use. We don't need to provision a dedicated SQL pool. You can, but there is not one provision for you. You don't need to provision any Spark pools. You don't need to integrate Power BI Workspace with your Synapse Analytics workspace or use the pipelines feature. Pipelines feature is very useful for orchestration, but essentially you can use Synapse Analytics purely for the SQL Serverless processing engine. Now, when we're connecting to the Serverless SQL endpoint, it isn't just BI tools. It isn't just Power BI that can connect. We can use client tools. Now, in the context of someone developing a Power BI data flow using Serverless SQL, well, they've got access, if the appropriate permissions are given, to use client tools to query the data as well, to analyze. Instead of just using the Power BI Dataflows feature to build, they can start analyzing that data on an ad hoc basis using Azure Data Studio, SSMS, and it has support for Python. So if data scientists want to use the power of Serverless SQL to process that data, the endpoint is available for them. Now, when we talk about Power BI query folding, What we mean is that when Power BI connects to a data source that supports this feature called query folding, when you apply transformations within your Power BI Dataflow, and indeed Power BI Desktop, if those transformations can be pushed down to the data source itself and use the power of that data source, Power BI will do that. So, for example, if we have a data flow and we're using a group by, which is a transformation in a data flow, to aggregate the data from our data source. Now, if we're using data from a data lake, this is certainly the most common usage that I use this for, is to take that volume of data in that data lake and shrink it as it's coming into Power BI. And essentially what the group by transformation will really be doing behind the scenes is aggregating that data, and it can push the query back down to the Serverless SQL engine. It can use the power of Serverless SQL to run the SQL query and return that aggregated data to the data flow. Now, within the Power BI service itself, within Dataflows, we have a visual representation of whether the query is being folded, whether Power BI is able to push the processing, the transformation, down to the data source. So on the left-hand side, we can see a data flow, a series of data flow steps, and you can see that we have a green line to represent that our query is being successfully folded down to the data source, in this case Serverless SQL. On the right-hand side, we can see that we have a transformation that has been added that has now prevented the query being folded, i.e. the SQL itself being generated and sent down to Serverless SQL. However, this is a very visual process within Power BI Dataflows, so you're going to see if your query is being folded or not. And in fact, you're able to see the actual execution by right-clicking the appropriate step and choosing the option. Now, when we talk about supported file types and file formats, I'm going to say that, as we said, we've got 3 supported file formats so far: CSV, or delimited text, Parquet, and JSON. Now, I'm concentrating on CSV and Parquet during this session, but JSON supports the open JSON process, and it's similar to using CSV in connecting to that data and pulling it through. But you have the JSON constructs available to you within Serverless SQL to explode out the contents of JSON. So on the left-hand side, we've got CSV and an example of selecting the data from the CSV location. Now, the with statement in the SQL statement is providing Serverless SQL with 2 things: a data type and where it needs to get the data from. So with CSV, we need to specify an ordinal position. So in our example, product key, position 1, customer key, position 5. And Serverless SQL will read the entire contents of that CSV file. Now, we switch to Parquet, which is a compressed file format. And Parquet contains 3 main objects. It contains the data itself. It needs the data to be contained in the file itself. It also contains the schema, i.e. the data types, the names of the columns, and statistics as well. And the statistics are important because Serverless SQL will only read the data necessary to support the query. In that, when you're selecting from a Parquet file, you can select specific columns just using the name and a filter, and the Parquet file itself will support that predicate pushdown and only give you the data that is required. So what objects can we connect to in Serverless SQL? Because we can connect using the SQL endpoint, what are we able to see? What are we able to trigger? So we've got four main objects that we can trigger. We've got tables and views, stored procedures, and native SQL. Okay, so we've got support for those four objects. However, with tables, it's an external table, remember, there's no data contained within Serverless SQL itself. However, Power BI sees it as a table. Now that table is pointed to a folder location within Azure Storage. With a view, we can again select data specific to a folder location, but we can also introduce some partition pruning. I'll talk about that in another slide. And we've got stored procedures. Serverless SQL has support for stored procedures where we can write some conditional logic. We can return data to the client, i.e. Power BI, and native SQL. We can take the SQL that we write and use it. However, we go back to this concept of a foldable query where Power BI can push the SQL, transform SQL back down to serverless. Tables and views, yes, it can do that. Stored procedures and native SQL, it's not able to fold that query down. What I would say is if you're using stored procedures, you're probably already transforming the data to a certain degree. So we're going to jump in to see what it looks like when we create our objects. So what we've got here is 3 CSV files in storage, which is set up as an Azure Data Lake Gen 2. And we'll also show 3 Parquet files. So we're going to create them in parallel. We're going to create 2 external tables to support our data flows in parallel. Now, as you can see, we've got a total of about 4.5 gig for our CSV files and around 500-600 gig for our Parquet. So when we jump to the Synapse workspace, we're going to go into the Develop tab and expand our SQL scripts folder. And we can see we've got a series of scripts to support what we're doing. The very first thing we need to do is we need to create a database within the built-in, the Serverless SQL pool itself. As you can see, I've got several databases there that already exist. Okay, so we're going to run and create SQL Data Saturdays. Regular use database statement to switch the context to that database. And we can create a schema to logically separate our objects. And we're creating credentials to allow us, or to allow my user account, to connect all the way through from Power BI through Synapse Analytics to the underlying storage itself. Now, to support creating tables, I need to create an external data source, which points to the container in my data lake. Okay, so I've got the data lakehouse container there, which contains my folder structure, contains my CSV and my Parquet files. Now I've got my location in place, I can create my file formats. And I'm creating 2. I'm creating a Parquet, which, as you can see, doesn't really have a lot of information other than to say the format type is Parquet, because the Parquet file contains the schema information itself. We're going to create the Parquet and the delimited text file format, which has this how our data is formatted in our CSV file. And we could create our external tables. Okay, so we're using the keyword external when we're creating that table, because what we're doing is we're essentially casting a structure over data stored in that data lake. I can specify the data source itself and then a location if it's a specific location, and I can specify my file format. So I'm creating two tables here, two external tables. It has the same data. We're creating an external table for Parquet and an external table for the CSV. So as you can see, the location and name and file format is different in these two statements. So once we've created our external tables, and what we're going to do is we're just going to have a look at the metadata that's been created here. So if we refresh, we can see that we've got our SQL Data Saturdays database available. And from our folder structure, we can have a look at external tables, and we've got our tables. We can see our columns, the data types associated to those columns, and we can do a quick SQL script to select the top 100. So if we were to run that statement, that's going to query the data that's stored in that data lake. Now, we can see the external resources that are created. So we've got data sources and two file formats, the CSV and the Parquet. And finally, we're going to query that data to actually show that the data is being selected from that data lake location. And as you can see, we have our DW schema that we've created in script 1. So now if we flip to the select, we can do some basic selects to make sure everything's working okay. We switch the context to our SQL Saturdays database, and we're just going to run some basic counts. Now, the Parquet files and the CSV files, they contain the same data. It's the same number of rows. So we've got around 22 million rows across those three files. Now I've used 3 files. Those files could be broken down into smaller chunks. If we want to have a little look at the data, we want to peek inside the data, we'll run the top 5 statement. And we can see that we've got the data, we've got our product key, order date key, exactly as we specified in our external table statement. And we've got our aggregate queries there. So what we'll do is we're going to run one of those. And we'll see some results returning. Okay, so now we've set up Synapse Analytics, we're going to jump to Power BI and we're going to create our data flow. So I'm now going to bring in my data flow window. Okay, and we're going to add a new entity. Okay, and we're going to have a little look for Azure Synapse Analytics SQL DW. I use this connector. You can use Azure SQL Database. It's a SQL endpoint. But I'm going to use the Azure Synapse Analytics endpoint. And from here, we're going to select our server endpoint and our database. And when we connect, we can see our 2 tables. Now for this example, I am going to select the Parquet table, and we'll wait for it to return a representation of our data, and we're going to transform that data. Okay, if we have a little look on the right hand side, we can see this step. If we right click that and select View Data Source Query, we can see the statement that it's being sent to the serverless engine. Now, what we're going to do is create a transformation. And this is possibly one of the most common transformations that I use. And we're going to aggregate by 8 columns, by the key columns that's in our data. So we'll do ship date, we'll do the customer key, we'll do the promotion key, currency, and the sales territory. And I am going to introduce a row count column. I'll introduce a total order count, which is I'm going to sum from my order quantity column. And finally, my total sales amount. So when I have a look at sales amount, I'm going to click OK. Now, while Synapse is working on that, I'm going to show a little peek of what's going on behind the scenes. So we're going to go to our monitor tab, and we can actually see that these SQL requests are being sent to the serverless engine. I'll come back to this monitoring later on. So as you can see, we've got our transformation that's happening on the right-hand side, and we've got this green line here that's indicating that the query is being folded. It's being pushed down to the serverless SQL engine. So if I right-click that transformation and click on View Data Source Query, we can see that we're selecting the appropriate data, we're aggregating, and we're grouping. And that's being pushed down to the serverless SQL engine. So you can imagine if you have a significant amount of data in your data lake, and your data strategy requires some nimble analytics around the data that's stored in your data lake. Well, you can use Power BI, still pull that data, but introduce that serverless SQL engine in the middle to crunch and aggregate that data down, reduce the size of that data that you're pulling into Power BI. And if we click OK, we'll save and close, and it will validate those queries. And we'll just call it data Saturday internet sales. Refresh, and now our data flow is available for our data analysts, our BI developers to come in and use that data. Now, when we talk about incremental refreshing, Power BI supports the ability to only load the latest data that's required, because if the situation dictates, yes, you can load all of the data from your location. However, if that data is being streamed in, being batched and loaded into the data lake, and it's an append model in that data is being added, then you don't really want to have to refresh that data every time. If you have a datetime column that's exposed via your serverless SQL engine, then you can use the incremental refresh settings within Power BI. You can choose your datetime field, you can choose the time period in which you would like to initially store, and then refresh the number of the amount of data based on your time period. There's a couple of things here to note, is that when we're refreshing based on an external table, that external table is pointing to a location in your data lake. If we're using Parquet files, then that incremental refresh is going to be able to take advantage of the filtering that's available within those Parquet files. However, it's still going to have to scan those Parquet files to get that data back. When we look at partition pruning, in the context of Serverless SQL, we can use a file path function. So we can actually tell Serverless SQL where the data is specifically in a folder structure. So in terms of using a view, we can select from that source storage, pass in a value into this file path function, a year, a month, or a day, and only scan those folders that meet that criteria. Now, when we look at the loading performance, now I'm going to caveat this and say that if you follow Chris Webb, who is one of the gurus who now works for Microsoft in the Power BI team, Chris has done actually a lot of analysis around the performance of connecting to data lakes. So I'll probably tweet a link out to Chris's blog because it's a really great read. But the performance that we get when we're using that serverless SQL engine versus the Power BI native data lake connector is really based on essentially how much data you're loading in. Now with serverless SQL, it's able to crunch that data in that engine and return it to Power BI. When Power BI has to transform those files, what it really needs to do is it needs to load those files in, break apart those files, and start dealing with the data within the files itself. So what it's doing is, if you've got some CSV or Parquet data, you're going to be selecting that data into Power BI, and then the Power BI engine is going to be doing its transformation. If your data is at a certain volume, that may work. Once the data volumes and transformations get complex and large, it may make sense to switch to using serverless. Now, considerations. It is a chargeable service. When you provision Azure Synapse Analytics, you're not going to be charged for anything until you start using the serverless engine. Now, the serverless engine, the pricing structure is based around the amount of data that you're processing. It's not time, it's not compute power. It's purely how much data you're processing. And it's not in increments of 1 terabyte as well. I know that was a previous question, is that if you process 100 meg of data, you'll be charged for 100 meg of data. So we're currently looking at £3.70 to process 1 terabyte of data. Now that includes selecting the data, transferring the data between the underlying serverless SQL nodes and returning that to the client. So when you're developing, it's very much worth using a subset of your data. Use smaller files so that when you're developing, writing SQL queries, you can test on a very small subset. And it's additional infrastructure, because essentially we're adding another service into our data architecture. However, as we've seen in the endpoint connection, where we have Management Studio, Azure Data Studio, Power BI, Python, we've got a variety of tools in which we can connect to the engine and utilize. So it may be worth having that service available for data analysts, for BI developers to query that data. Now we have monitoring. Monitoring is very, very important generally, but with serverless SQL, it is going to show two things that I'm very much focused on. It's going to show the SQL that's being generated and run against the serverless SQL pool, but it's going to show me how much data is being processed. Now, this is key. If you're budgeting, if you're putting together your proposal to use Azure services and you're using the Azure cost calculator, you need to include the data processed. You're going to have to include that fee based on the data that you're processing, based on the scenarios, how often it's being loaded. You need to cost up. So what we'll do is we'll jump into that monitoring aspect. Now, if we have a look at our monitor, it's available on the left-hand side in Studio, and we look at SQL requests, okay, we can see that we've got our built-in pool that's being selected, and we have our queries that are hitting the serverless SQL engine. Okay, so we can see that Power BI is reasonably chatty when you're developing. So that's another reason to use small files, because it's doing previews, it's connecting to and loading that data in. So we can see some top 10s. But if we click on our request here, okay, actually what I'll do is I'll just bring up the query on the right-hand side. We can see the query that Dataflows is sending down to Synapse Analytics. Okay, we can see that group by, we can see that sum, we can see that count. It's all there, it's visible. And we've got this data processed. So that's, to me, is the second most important column. The first is, well, what query is being run? What SQL is being run? The second is the data processed. Okay. Now, in the Microsoft documentation, it describes scenarios pulling data from Parquet, from CSV. It has to read the schema of the data. So there is a little bit of overhead in terms of an extra bit of data that's being processed. The data that you see at rest doesn't necessarily translate to the data processed. So what you'll need to do is, when you're working with the serverless SQL engine itself, and you're querying data, when you're working with client tools, with Power BI Dataflows, you're going to have to do your analyses based on the data that's being processed and the data that you're seeing at rest. Now, you might be worried and thinking, okay, I'm being charged for the amount of data that's processed. Well, what's to stop somebody querying all the data all the time and us being charged a very large amount of money? Well, we've got the ability to limit. If we go into the manage section, and we've got our built-in pool here, we can see that we have a cost control. And we can see, well, how much have I used today, this week and this month? And I can control that. So I can say, well, I'm only going to let you use 1 terabyte per day or 2 terabytes per week, with a total of 4 terabytes a month. So you do have control over that. Now, there is a blog post available for reference, which will take you through the steps to create the Synapse Analytics instance, to create the external tables, which means creating a database, creating your file formats and your locations, and ultimately using that data flow. So that's available there. So I think I will hand over to any questions that's come through at all.
Thank you for your great session, Andy. There are no questions for you.
So what I will expand on in these few minutes.
Yes.
And obviously you can tell me when I am officially finished, but this is very much still in motion. So what I would say is, please connect with me on Twitter, because this is evolving all of the time. As you know, if you're working with both Power BI and Synapse Analytics, features are being released every week, every month. We're having new features being added. So it's always worth just checking in to see, well, has anything changed? Are there any changes or enhancements? So in terms of the Power BI Dataflows usage with Serverless SQL, if you're building out your query within Power BI, if you're building it out within the Dataflow service itself, then pay attention to that query folding section or the query settings on that right-hand side, so you can see exactly what's being pushed down and if it's being pushed down to the Serverless SQL engine itself.
Yes, in my opinion, there is no doubt that SQL Serverless it is moving in the right direction.
Yes, there have been some discussions around additional features that maybe would be beneficial to be added in the future, but we very much feedback, we listen to and we talk to Microsoft, and we ask Microsoft very nicely to add add features that really help us. The stored procedures that I just wanted to highlight was a very much an under the radar feature that got added, in that in the official documentation, the ability to create stored procedures and use stored procedures within Serverless SQL was added without much fanfare. And I know that it sounds very basic, like, well, stored procedures, I mean, they've been around for decades. Why be excited? Well, with stored procedures in SQL Serverless, we can now orchestrate and introduce logical processing into our code. So one of the things that I or pattern I like to do in Serverless is, when I'm writing data out to the data lake using the create table as select statement, I almost use that create table statement as a staging process to output data to specific folders in my data lake, and then I can use a view to cast a structure over all of that data. So once you start using the Serverless SQL engine in the context of data warehousing or aggregating data, it really gets the juices flowing in terms of what you can do.
Yes, I have read that the data cache will come soon. Will be an interesting tool to further improve performance in SQL Serverless.
Yeah. So actually, I've got a couple of questions that's actually just come through.
Yes.
Yes. So Mark, fantastic question. I do have another session around building a dimensional model using Serverless SQL, but yes, it would basically be the same process. In that session, what I'm doing is I'm selecting the source data and I'm transforming that into a dimensional modeling structure. So, denormalizing my source data and writing that out using Serverless SQL, generating a surrogate key. And then when I'm creating my facts and outputting, I look up that key from the from the data lake location that's storing my dimensions. And is it possible to connect Power BI to Synapse in Serverless? Yes, you can. Yes, you can. So within desktop itself, you'll have exposure to connect to a SQL database or Azure SQL data warehouse. Obviously, the consideration is that if your Synapse Analytics security has, IP whitelisting, anything that is going to limit your connectivity, then that has to be taken into consideration. But from a functional perspective, no, you can connect Power BI Desktop directly to that SQL Serverless engine as if it was just a regular database. So nothing special there other than making sure that you use that endpoint. This, if I go back to here, and we have a look here, and this is my demo instance. So if you've created a dedicated SQL pool, AKA the SQL Data Warehouse Service, we're not allowed to call it that anymore. You've got your endpoint here, but you've got your dedicated serverless SQL endpoint. So proof in the pudding is that if we open up desktop, and let's get data. Okay, if we search for Azure, okay, we can see Azure Synapse Analytics SQL DW. Now, just a note on these connectors is this isn't necessarily dedicated to serverless. It just is the connector to connect to Synapse Analytics. So we can put our server in, and let's say SQL Data Saturdays. Now, we could connect in direct query, and I'm going to do that now. I know that direct query is incredibly useful in this scenario because, again, we may not want to pull in all of that data. So what I'll do is let's log in to desktop. And from a security perspective, we'll log in using MFA. Okay, and when we connect, and there we go, we've got our tables. So I'm going to select that Parquet, and we can treat it exactly as if we were doing the data flow in the Power BI service itself. Okay, so we have one more question that I'll answer very quickly from you, Janssen. Where would you create the star model in a SQL Serverless when using Parquet in the data lake, or in Serverless? Or yes, so again, I'll tweet out a link to my dimensional modeling session. It's a short session that I'm going to turn into a longer session, but essentially what I'm doing is we're using Serverless SQL to connect to our source data in our data lake, our non-dimensional data. We're transforming that data using purely SQL, and then using the create table as select to push that data as Parquet into another folder location in our data lake. So if you can imagine a folder location of /dimensions, /facts, we're populating our dimensions. And then when we create or write SQL or use our data flows, we can connect to views or tables that are casting structure over those dimensions or facts tables. And again, with incremental loading, we can actually use that create external table as select to write out data to a hive-like partition structure. So yes, I think more and more people are going to be looking at how you can use the dimensional modeling, the star schema concept within serverless SQL, because at the very beginning of that short session that I do in dimensional modeling, I say the reason I want to do this is I'd like to leverage my existing SQL skills. I'm not much of a Python or Scala developer, so I want to use my SQL knowledge to transform that data and push it out back to my data lake as denormalized dimensions, as facts that contain keys. Now, I think more and more people are going to be looking at this as a way to augment an additional or a centralized data warehouse, because if you can imagine, you've got dimensions stored in a data warehouse, well, they could be exported to the data lake and used for incoming telemetry or activity data that maybe you don't want to push into a data warehouse. You still want your conformed dimensions to be used across your estate. So yeah, a couple of great questions there on the star schema dimensional modeling aspect.
Okay, thank you, Andy. Thank you very much.
Thank you.
We hope to meet at the next event in a non-virtual way.
Say again?
Italy. We hope to meet you at the next event in a non-virtual way in Italy.
Oh yes, yes, I am. You know, I'm very much, I'm very much looking forward to that. As and when it's safe. So I would say, keep safe, everyone.